on number 6. On which page? On this one here? We're still missing 4 pages? Or did it get out of order? Wait. Let me reopen this because this thing is file is. Let me close this out and let me reopen it. Let's try again. See if the order's off. So, was it this page here? Okay. So now we got to do number 6. Find the average rate of change. Did we do any rate of change? Yeah, we did towards the end, right? We already used rate of change. What's another word for rate of change? Slope. Okay. So of these 3, which is the easiest one to find slope? On number 6. Right now we're working on number 6. Yeah, C. Why? Because on linear functions, slope is constant. It doesn't matter what the interval is. The slope is always going to be the same. So since they give me that function h there, what's the slope of that function? 1. And the rate of change is always going to be 1. So this is just 1. Right, and equals 1. Next week I told you I have a Google form. Remember on the Google form, just put the number. On the other ones, we're going to have to use slope formula. So let's see, when x is 1, see, so on this first one, the exponential one, when x is 1, y is -3. So that's going to be one of the points. When x is 3, y is also 3. So 3, 3. All I have to do is find the slope between those points. We'll use slope formula. Subtract the y, so it depends on which y you want to use first. I'll just use the top y first, so 3. But then change the sign of the second coordinate. So if this is my next y, I'm going to change that to +3 over the x is 3 minus 1. That gives me 6 over 2, which is the average rate of change over that interval is 3. We do the same thing for the parabola. Okay, we have to find the points. The point here is 1, -4. And then when x is 3, y is 4. So slope here, the first y is 4, minus -4 is +4, 3 minus 1. So it's 8 over 2, which is so if you were to be asked which of these actually had the biggest rate of change over that interval? Which one had the greatest rate of change over that interval? In this case, it was the quadratic. But if you learned something from yesterday, if I expand the interval, if I make the interval bigger, especially the more I go out towards infinity, towards positive infinity on the x, the more that I head out towards that way, which one of these should have the biggest rate of change? Exponential. What should have the second biggest rate of change? Quadratic. And then linear is usually the slowest of the bunch. Find an interval of x over which all 3 graph functions have the same average rate of change. Okay. Well, we're kind of stuck here because since one of our functions is linear, like there's only one type of rate of change that one can have. This one here, you're stuck at 1. So basically, what they're asking you here, and I'm not even going to get too fancy on this one. I could get really algebraic with you, but I think I'm going to lose you on that one. So we said that rate of change is slope. What did you learn slope as when you first learned about slope? What's that catchy little phrase that you learned? Now, what's that catchy little phrase that you learned to memorize slope? When you were first taught about slope? Rise over run. Okay. So if you look here, no matter where on my line, the reason why my rate of change is 1 is because no matter where I am, I'm rising 1, running 1, rising 1, running 1, rising 1, running 1, rising 1, running 1 for the entire line. So just to make it simple, can I find any other place on my functions here where I have that same rise and run? Well, yeah, sure. Look on the quadratic, it would have to be there. On the exponential, it would have to be here. Because we're experts on and I'm not gonna write it in this box. Actually, here, let's make our own little boxes. Let's make 3 boxes here. Kind of how we have it up there. I like that better. And then in each of those boxes, we'll write the interval where the rate of change is, in this case, 1. Because, these first 2 have a bunch of different rates of change depending on what the interval is. But the last one, the linear one, only has 1 rate of change throughout. So we're stuck. That's what it has to be because that's the only thing that one can be. It's dragging everybody else down. What is the interval for the exponential one? In between what x's is that rate of change 1? Between where on the x-axis is this rate of change 1? Between 0 and 1. We've learned several ways to write intervals, of which now probably hopefully the most familiar, that's what gets stressed the most, at least in this school, and probably because of the book, is interval notation. So how would I write in between 0 and 1 inclusive? Bracket 0, comma, bracket 1. Not the only way to write it. It could also be written as an inequality, but it's probably easier that way. What's the interval for the middle one, where the rate of change is 1? In between what x's am I rising 1 and running 1? Also 0 and 1. And I guess now that I'm seeing this, it kind of gets me to want to reread the question, because maybe they were just talking about name one interval where they happen to all be the same. And yes, coincidentally, they happen to all be the same in between 0 and 1. So maybe that's what they meant by this. But in reality, if we were to interpret this the first way that I interpret it, which is just, hey, under which even if they're all separate, under which interval do these have a rise and run of 1? Well, under which interval does this have a rise and run of 1? Everywhere. How would I describe everywhere in interval notation? You could say that's what I don't know what you look. You write like ARC, but ARL, but then you know that. No, I don't know why you always write. You write like ARC, like could it be ARN, all real numbers? What? Isn't it you that always writes it on the test? That you write like AR or something? You just said all real numbers. But again, now that I happen to notice that these first 2 had the same one, that's probably what they meant. Like to find one single interval that just by coincidence these all happen to have the same rate of change, and that would be if this last one has the same rate of change everywhere. Yes, it also happens to have that rate of change over the 0, 1. That makes sense to you? Jason, blink once for yes. All we're doing is finding slope. Caleb? Determine the domain and range. Is this the last page that you have? So determine the domain and range of each of the following graph functions using interval and set notation. Okay, perfect. Let's do both. What's the domain? Well, first of all, let's say what type of fun, and actually, hint. A big part of the quiz on Friday is just going to be naming them. So it's not going to be multiple choice, but please be able to name them on your own. What type of function is this? Yeah, exponential. If you want, exponential is the key word. Make sure you say exponential. If you say exponential growth, because this happens to be a growth, great, even better. So you don't have to just at least know that it's exponential. Okay, So this is exponential. What type of domain do all exponential functions have? Huh? Negative infinity to positive infinity. Yeah, so in interval notation, that's what you would write. Negative infinity to positive infinity. How would I write that in set notation? Well, set notation really means that you're supposed to write this like x with that. But really, it means you're supposed to use inequalities. So the way that you would write that is supposed to be, I don't even know what to put. Negative infinity. Yeah, I'm not going to be able to fit it. See, like, fit it over here. You guys, pencil, it's easier to write, but it will be x. Negative infinity is less than x is less than positive infinity. That's how you write it in set notation with braces. I have to go back and look at the quiz again, but I'm pretty sure interval notation is going to be the one that's stressed the most. We do have a quiz review set for tomorrow. Usually those quiz reviews are very similar. What's the range here? This is going from -3 up to positive infinity, and it doesn't touch either one, so it would be parentheses -3, parentheses positive infinity. How would you do that? Remember, set just means, this one I could probably fit here. Y colon braces. Set notation just means use inequality signs. If it's continuous, use an inequality sign. So since this is, and this I've actually done for you. I haven't done it with the braces, but I've done it before for you. Another way of saying this is just saying y is greater than -3. I doubt I would take away points if you forget the braces. But the key is that the inequality has to be correct. Nakai, give me the domain of the next one. What is the domain of any parabola? As taught to you. All real numbers. How do we write that in interval? Now, pretty sure it's you, but if you are explicitly told that you have to write something in a certain way, and you write all real numbers, normally I let that slide if you just write all real numbers, but if you're being told to write it a certain way, you have to write it that way. So like if you're told interval notation, you have to know that all real numbers is negative infinity, comma, positive infinity. What would the domain be in set notation? The same thing as it was on this last one. X braces negative infinity less than x less than positive infinity. That's just saying that all the x's are in between those two numbers. It's a different way of writing it. How about the range? Just like with exponential, the range is limited, but instead of an asymptote, what we have is a turning point. Jason, can you give me the range of that parabola that's in the middle? How low does it go? How high does it go? The parabola, we're looking at the one in the middle. Say it goes lower than -2. Yeah, it goes from -4 up to where? Up to where? Yeah, and how would you write that in interval? Well, does it touch -4? Yes, it does. So that takes a bracket. But then positive infinity takes a bracket. Yes, it has to be perfectly written like that. That is interval notation. Anything else is wrong. You need to know that by now. How would you write it in set notation? You write the y, the colon, the braces. And then you would just say the y, but now instead of greater than, because unlike an asymptote, since the turning point actually does touch -4, it would be greater than or equal to -4. And then close the braces. The line should be the easiest thing of all. What's the domain of a line? Yeah, it's all real numbers. What's the range? It's also all real numbers. All lines, as long as they have both an x and a y, which these two, like any line that is diagonal, goes forever up, forever down, forever left, forever right. So in interval notation, negative infinity, positive infinity, the domain would be x such that that negative infinity is less than x is less than positive infinity. The range would be again negative infinity to positive infinity. And then y such that negative infinity is less than y, not less than x, less than y, less than positive infinity. Did everybody write? Why the long face? Too easy. This next one says graphed, but nowhere in this unit have we stressed graphing. Plus, like this implies that the things are graphed for you, and they're not. But I think we can answer all these questions even without the graph. So, what word can be used to describe a quadratic? What is the domain of any parabola? Every single parabola, the domain is going to be all real numbers. So negative infinity, comma, positive infinity. I do not need to look at a picture for that. X such that negative infinity is less than x is less than positive infinity. That's notation. How about the range? What is the range of any parabola? What is the range of any parabola? How could you describe, generally speaking, what the range of any parabola is? Okay, let me make it easier for you. What does the range of a parabola depend on? Yeah. The vertex. Are they going to be for the vertex up or the vertex down? Depending on where it's facing. Can you tell where this parabola is facing? Oh, how do you know it's going up? Because A is positive. So I know the range has to be going up. But going up from the vertex, well, the nice thing is that this is a vertex form. Can you tell me what the vertex is of this parabola? Man, don't forget you got to change the sign of the of H there. So it's going to be positive 1, negative 3. The more important one, because we're talking about range here, is that negative 3, that K. Because K is negative 3, that's the Y of the vertex, and I know that we're going up, my range here is going to be from negative 3 up to positive infinity. Negative 3 gets the bracket, because the vertex will touch it. Positive infinity gets a parentheses. Set notation might be easier here. It's just Y greater than or equal to negative 3. How about B? What is B? What type of function is B? Exponential. What is the domain of any exponential function? Yeah, all real numbers, so negative infinity to positive infinity in interval notation. In set notation, x such that negative infinity is less than x is less than positive infinity. What does the range of an exponential function depend on? The asymptote. Okay. Now it's either going to be above the asymptote or below the asymptote. What determines that is also A. Remember, 2 is the base. What's the A there? What number is in front of the 2? is a positive. Yeah, it's a positive 1. So this is going to be above the asymptote. So we're going to go greater than whatever the asymptote is. The asymptote is at k here. So here k is 1. So if I want to say everything above 1, but see the difference is an asymptote you don't touch. A vertex does touch the line, an asymptote doesn't. So now the 1 is going to get a parentheses. Infinities always get parentheses. How would I write this in set notation? Y is greater than 1. Not greater than or equal to, greater than 1, because you can't touch the asymptote. And then finally, C is the easiest because who cares what's there? Well, the only thing that matters is, as far as domain and range goes, what type of function is that? Linear. What is the domain and range of any linear function? Yeah, unless there was an x or a y missing. If it only said x equals a number, or if it said y equals a number, and it only had one variable, then either the domain or range would be limited. But this has both a y and an x, so it would be diagonal. The negative infinity, positive infinity would be both the domain and the range. And then in set notation, x such that negative infinity is less than x is less than positive infinity. And then the range y such that y negative infinity is less than y is less than positive infinity. Caleb, no. You said that you're going to be a good boy from now on. If you're lost, say something. Last 3. If we only consider the functions linear, quadratic, and exponential, which is the only one that could have a range of negative infinity to positive infinity? Linear. Okay, we've seen that we've now done 6 of these. The only one that could have the range go everywhere is linear. If we only consider those 3 again, which is the only one that could have a range of 2 to positive infinity, but look at what's on the 2. It's parentheses, meaning that it doesn't touch the 2. Which one would that be? Huh? Exponential, good. Exponential. And then not by process of elimination, okay, not by default, but if we're talking about range again, which is the only one that could go to positive infinity, but now have a bracket, meaning it touches quadratic. We have now done pretty much that entire packet. It was a 4-day packet, and we knocked it out in 2.5. Are there any questions there? The good news is, like Marmy, even though you've been absent, tomorrow we kind of have a 1-day review of what we've just done the last 3 days. So we pack it all into 1 day, and then we take the quiz on Friday. And then we celebrate on the weekend by studying and doing our homework. Let's see if we can get